Assalamualaikum. Let's continue with chapter 4, normal distribution. So for this normal distributions, there are 4 subtopics. The first one is normal distribution, applications of the normal distribution, central limit theorem, the normal approximations to the binomial distribution. So the objective of this chapter is first to identify distributions as symmetric or skewed, identify the properties of a normal distribution, find the area under the standard normal distribution, given various z values, find probabilities for a normal distributed variable by transforming it into a standard normal variable. Okay, and then next, we're going to find specific data values for given percentages using the standard normal distribution. Use the central limit theorem to solve problems involving sample means, and then use the normal approximation to compute probabilities for a normal variable, binomial variable. Okay, so what is normal distribution? So normal distributions, many continuous variables have distributions that are bell-shaped or called approximately normal distributed. So bell-shaped. So how is a bell shape? For example, let's say we have this one. So this is, we call it as a bell shape. Okay. Okay, so the theoretical curve called the bell curve or the Gaussian distribution can be used to study many variables that are not normally distributed but are approximately normal. Okay, let's take a look on the normal distributions formula. Okay, so this is y equal to exponent power of negative x minus mu power of 2 divided by 2 sigma power of 2 over sigma square root 2 pi. So pi here and exponent here constant, and we use exponent value which is 2.718, and then pi value is 3.14. So mu here is referring to population mean, so this one is for mean, and sigma is a population standard deviation. Okay, so the shape and positions of the normal distribution curve depends on 2 parameters. The first one is the mean and the standard deviation. Okay, so each normally distributed variable has its own normal distribution curve, which depends on the values of the variable's mean and standard deviations. Okay, you can see the difference between figure A and then figure B and figure C. So for normal distributions, the middle one usually for the mean. So here, mean, or we call it as a average. Okay, so curve, this curve referring to standard deviation. Okay, so when you look at like this, different mean but same standard deviation. So meaning that we have two. Okay, so this one is the first bell curve, the second bell curve. So you can see that this is same. So meaning that, okay, so this is a standard deviation, this one is for mean. Okay, so here we can see that if there are two different curves in one graph, so you can see that we have two different means but same standard deviations. Okay, because this is same, you can see that this is symmetry. The blue curve and the brown curve is symmetry. Okay, and then see different means and different standard deviation. You can see that mean This one is for the curve 1. The curve 2 is more higher than compared to curve 1. Curve 1 more shorter than curve 2. Okay. This one is same mean. Same means but different standard deviations. You can see that the curve 1 shorter than curve 2. Okay, so curve 1 referring to standard deviation 1. Curve 2 referring to standard deviation 2. Curve 2 standard deviation 1. Curve 1 standard deviation 2. Okay, so the normal distribution properties, the normal distribution curve is bell shape. Okay, you can see that this is a bell shape. And then the mean, median and mode are equal and located at the center of the distributions. So the normal distribution curve is unimodal, only one mode. The curve is symmetrical about the mean, which is equivalent to saying that H shape is the same on both sides of a vertical line passing through the center. Okay, so the curve is continuous. There are no gap or holes for each value of x. The curve never touches the x-axis theoretically. So you can see that this is a curve. So the curve must be continuous. You can't draw like this. Cannot. Okay, no. So the curve must be continuous. You also can't draw like this. Cannot. Because the curve never touches the x-axis. Okay. So the curve must not touch the x-axis. So this is a curve. And then the mean, median and mode are equal and located at the center distribution. So mean, and then we have median, and we have mode here. Okay. So only one mode here, unimodal. Okay, so the total area under normal distribution curve, okay, this total area must equal to 1 or 100%. Okay, it must equal to 1 or 100%. Okay. Okay, look at this one. So this one, in the middle we have mean here, and then about 68%, starting from mean minus 1 standard deviation. Mean plus 1 standard deviation. For 95%, mean minus 2 standard deviations, mean plus 2 standard deviation. About 99.7%, mean minus 3 standard deviation, and mean plus 3 standard deviation. Okay, so the standard normal distribution is a normal distributed with a mean of 0 and a standard deviation of 1. So the z value is the number of standard deviation that a particular x value is away from the mean. The formula is finding the z value is this one. So z equal to x minus mu divided by sigma. So this one for value, this one is for mean, and this one is standard deviation. Okay, so let's take a look on the first Example, this one is area under the standard normal distribution curve to the left of any z value. So you can see that this one, so to the left, you can see that so if the z value here, so meaning that to the left here, so this one 0, okay, referring to mean. So here, if z value is here, so meaning that starting from here until here. Okay, and then to the right of any z value, if to the right, mu, okay, here, z, or here, starting from here until here, for the z value to the right. And then in the middle, between the two z values. So between the two z value, it can be between mean, also can be here, let's say this is mean, and then so this one is negative z1 and negative z2, this one positive z2 and positive z1.